off on a strong foot right here.
That's not bad.
All right. Good morning, America. This is Taylor and Will with American Filament. Today, this morning, we're going to be looking at CAD, computer-aided design, specifically Fusion 360 and Ondsel. Ondsel. Ondsel.
Which is a skinning. It is a comparative Fusion comparative skinning of FreeCAD, an open source CAD software that's a little bit unintuitive to use, and Ondsel is supposed to address that issue.
I personally have both personal and professional experience using Autodesk Inventor, SolidWorks, Solid Edge, Autodesk Fusion 360. Those are the big ones. And then, I mean, I've played around in a few other CAD programs, but nothing to write home about with any others. And then I got a fair bit of experience using SketchUp, but that's more 3D modeling and less CAD, so that's a little bit different.
Man, I'm so out of my league here. I've got about 15 years of graphic design and multimedia experience. A lot of it being self-taught, but most of it being to manage my career. But any 3D buildings experience that I have is probably as a young child in Minecraft. So nothing here to help me figure out what I'm doing. Although if you can see it, I did make this very nice dish for a pet, and that was much harder for me than I thought it was going to be, and I'm hoping to solve that.
Starting off, going off on a little tangent here. So I'm looking at, I've got your screen pulled up. We're looking at Ondsel right now, and I'm looking at this dish that you made, and I see there's a Z seam. It looks like on the wall right there.
Yeah, there is. It's bad.
What's up with that? Like, is that?
I wasn't sure myself, and that's one of the things I was going to bring up before we get started. Where did I screw up?
Well, I'm not saying you did screw up. Like, that might just be a display. That might just be how Ondsel shows you certain things, like based on how you modeled it. So, like, how did you create the wall? What did you do?
I'm gonna be honest with you.
Let me full screen this.
I cannot remember the specific way that I went about this. I think that I made a sketch and I extruded upwards, and it was just supposed to be a circle, but apparently the circle, I don't know if this kind of came into play when I beveled. It's beveled, right? It's not chamfered?
Yeah, beveled or filleted or round over.
Mm-hmm. When I rounded over
different softwares call it different things. I know Autodesk products call it a fillet, not to be confused with a fillet.
Here, I'm calling it a fillet.
What does Ondsel call it? What's the tool that Ondsel call it?
Yeah, I'm hovering over it. It's called a fillet, not to be confused.
Where is that? I can't. Oh, I see. I lost where your cursor was.
So I got the fillet and the chamfer.
Okay.
Right here.
Okay. Yeah, it might be that in Ondsel, when you have a cylindrical or just any like round 3D object in general, that it gives you a single seam on it when you make it 3D, when you make it three-dimensional, so that you have that as a reference to use in further modeling, because it looks like if you go back to the 3D model.
Oh God. Yeah, and this is gonna be the thing for me, is that
So you're in the sketch right now.
yeah, I have a hard time navigating this myself. I would think it would work if I did that. Just click on the body. I'm in part design. Let's go to where is that edit sketch? No. Oh,
Is it over on the right? Is there a exit sketch, finish sketch option anywhere?
Yeah, this is gonna be so slow because I've got to learn how to even navigate it. Like, you put me inside of some Adobe software and I will be fine. This, not so much. Okay, that did it. Yeah, you're right. Okay, so intuitively the right hand panel activated when I was in the sketch, and I should have probably just closed it. So yeah, that brought me back to it.
Yeah, so if you look at what you're working with here, you've got a three-dimensional cylinder, right? And if you hover your mouse over the wall, that it highlights the entire surface of the wall as what you're selecting. So like if you were to click on that, you would be selecting that entire wall surface. But if you hover over the seam it gives you, now you're just selecting that one line, which is like tangent. It's tangential to the surface of the cylinder. And that can be useful as a reference point for modeling.
Well, the reason I brought it up, and the reason I'm glad you're talking about it, is because when I did print the dish, which printed first try, and it was nice. It's done exactly what I wanted it to, except for the fact that this seam is a noticeable scarring. It's.
Oh, well, that's just going to be your 3D print is going to have a Z-seam.
Oh, in general, and so
yes.
it probably picked here to work with.
No.
Okay.
When you export this model as an STL, as a mesh file, it's going to take the parametric 3D solid, and it is going to translate it from being a solid object into a mesh surface. So like it has no volume or anything like that anymore. It's kind of like going from a PNG to a JPEG. Like you're gonna lose a lot of data. It's not that's not a perfect analogy.
No, because you actually can hold on to quite a bit of data in JPEG now. But
I was gonna say the STL or the mesh file, you're still holding on to a lot of data. It's just kind of different. Anyway, when you turn this from a solid body part into a mesh, it's going to be a mesh surface, and so it's just going to use triangles to define all of the surfaces of the part, and then when you put that in your slicer, like it's not gonna that seam, that one line seam is gonna be gone, and then your slicer is going to determine and place the Z-seam, your Z-seam, based on what you have your seam settings set to in your slicer.
Okay, then it's mostly the slicers, what you're telling me, and
yeah, so you can in your slicer, in the seam settings, you can tell it to have like a straight vertical line, or you can tell it to, on every Z layer, start in a different random spot, so that for every layer the seam is in a different spot, so there's no singular defined Z-seam. That's a good way to just hide it completely. Or
that's what I should have done.
or you can tell it to put it on the back or rear of the model. If you have something that you're printing that like has a very well defined, this is the front and this is the back, and then you can just hide it on the back of it where it won't be seen.
I know, I've seen the options. I know, and I was excited, I suppose, and didn't handle it thoroughly in the slicer. There's another one, isn't there, where you can put it on the most acute edge? Is that right?
Yeah, so it'll put it on like a corner, or
not
like
so helpful in a dish, a circle, but
yeah,
it is
but that's also a helpful way of hiding it, is if you put it on a corner. Yeah, so for the dish, it would you'd probably be best off telling it to, I can't remember off the top of my head exactly what the setting, the exact wording for the setting, but telling it to start at a random point so that there is no singular seam.
Got it. Yeah, that's what I should have done. It doesn't detract from the functionality, but I felt like I had failed somewhere, and just, I mean, in that one example with the seam, I was like, oh, I didn't do that the way it didn't. I mean, obviously it being there means it didn't come out 100% how I had envisioned it. But well, you know, it works. So that was great, being my first thing I've ever designed and printed and then used all successfully.
Yeah. I don't know if you noticed, that cup I printed for the food video had a Z seam on it.
No, I didn't. I mean, I didn't analyze it, critique it. It looked, I mean, because it looked great, but I get it. Yeah.
All right. So that is a brief look at Ondsel. I'm gonna switch the screen over to Fusion now.
All right, I'm watching you. So I'm assuming while you were in Ondsel, just to make sure, you did not see that I was also watching your screen, right?
No, all I could see was Ondsel.
Okay.
So briefly, I'm just gonna go over. I'm just gonna give a brief introduction to what CAD is, and how it relates to 3D printing, how it's useful for 3D printing. So basically, CAD is an acronym. It stands for Computer Aided Design. And it is a type of trying to think of how to word this. I was going to say 3D modeling. I don't want to use the term 3D modeling, because 3D modeling and CAD are kind of, or I mean, they're essentially two separate things, and a lot of times they get used interchangeably or confused or mixed up when they are actually two separate things. So CAD is like parametric solid body modeling for more like mathematically defined, constrained part design modeling, part creation, model creation stuff, more like engineering. And then you have 3D modeling, which is a lot more, so CAD is going to be stuff like Autodesk Inventor, Fusion 360, SolidWorks, Solid Edge, FreeCAD, etc., Ondsel, which we're going to be talking about more later. And then you have 3D modeling, which is a lot more freeform, and it's not 3D modeling is not going to,
so the way I kind of see it, tell me if I'm wrong, but and I think maybe other people are going to see it this way, is like when you're machining a part and the tolerances for your dimensions are pretty specific, then CAD, calling it CAD instead of modeling would, it's right, am I right? That's the term you're using, is for that that necessity to make sure that your parts are functional. Like if I'm trying to make sure that I'm replacing a part that I need in my work shed, then I need it to be to those specs. And modeling, 3D modeling, is more like sculpting using clay in a virtual space.
Yes. That is a good analogy. 3D modeling is a lot like sculpting using clay in a virtual environment. That is a really good analogy for 3D modeling. So yeah, stuff like Blender or SketchUp is kind of...
I know they all kind of interchange some.
SketchUp is a little bit in between being CAD and 3D modeling. It's in a weird gray zone in the middle. But Blender, off the top of my head, I can't think of any other.
No, it kind of stands at the front of the pack to the point that I don't know anything behind it.
Yeah, I can't think of any other 3D modeling softwares, but Blender is a good example. And it's not just like it's not just that functionally and fundamentally the way they work is also different. So in a CAD software, you are building a three-dimensional part, but you are like mathematically and geometrically defining the aspects of that part in a virtual like Cartesian environment. So you're going to be in a CAD software, your every three-dimensional part is going to start out as a two-dimensional sketch or a series of two-dimensional sketches. So like if you want to make a cube, you're going to be starting by drawing a square and then extruding a 2D square into the third dimension to make it a 3D cube. And that square is going to be constrained and defined by the constraints and dimensions that are placed on it. So like in CAD, it's going to be constrained to, if you tell it to be a square, it is like constrained as a square. And then in a 3D modeling software, it is... Oh, and then, so in CAD, it's I used the term parametric earlier. That basically just means that you have a revision history, or like a part. Each part has a revision history, so that you can go back in your revision tree and you can edit or look at all of the individual steps that were taken to create that part. So every single sketch or feature that was used to create that part. So like for the dish, for example, I mean, a simple cylindrical dish, it's going to be, you could make it probably in a series of 3. Well, if you revolved it, you could do a single sketch and then a revolve, and then you have a dish, and that's it, and it's just 2 steps. And then if you want to change any of the dimensions of it, you would go back to that first sketch, and you could change the dimensions of the sketch to change the wall thickness, the overall diameter, the height of the walls, etc. And then in a so that's what parametric means. It means that you have a captured design history, so you can, all of the steps you take for building a part are relative to one another. So if you go back to an earlier step and change it, it's going to have an effect on everything that came after it. And then in 3D modeling software, Oh, I keep going back to, I keep trying to move on to the 3D modeling software, but I keep forgetting to finish my train of thought with the CAD. So the other thing with CAD is you're building a solid body part or a solid part. That is a solid, enclosed, fully defined, like virtual digital part. So it has, so like when you make it, the CAD software, you're gonna tell it, you know, you're not just telling it, okay, I'm making a square and I'm extruding it into a third dimension to make it a cube, and it's just this like digital cube. You're also telling it, okay, this cube is made of steel, so you're defining a material, and the CAD software is able to take that information and it's like, okay, so this is now a steel cube, or like it's a virtual steel cube, and it has mass, volume, density, and other properties, etc. So you can do things like, you know, let's say you make your steel cube, you can then run simulations on it to determine behavior under exposure to certain conditions.
Didn't you? I think you told me one of those conditions could even be something like its ability to be aerodynamic.
Yeah, I mean, realistically, anything. I mean, there's a computer simulation to do anything. But in Fusion, just the basic ones are static stress, which is probably going to be your most common one, or
like load bearing, where it might have its weakest point.
Yeah, or like thermal stress, or exposure to certain temperatures, that kind of thing. Dynamic event simulation. That's cool. So like it is a like a virtually, I mean, it is essentially, it is a virtual representation of a real physical object with all of its real physical aspects defined. So like volume, mass, material, density, etc. And then in a 3D modeling software, you know, it's more like it's more freeform. So you're not starting in 2 dimensions and defining and constraining a shape and then turning that into a 3-dimensional object. It's more you start with a 3-dimensional or a 3D environment. And I know in Blender specifically, you essentially pick the starting shape you want to start with, whether you want to start with like a sphere or a cube or whatever, and it's like you have a pottery wheel in front of you, and you just throw down a blob of clay on it, and then you turn that into whatever you want. That's kind of how 3D modeling works, where you just go in, you throw down your blob of clay, and then you sculpt that into your object. And so you're not constraining it and defining it in the same way that a CAD software would, where in CAD everything is like mathematically constrained in a Cartesian 3-plane environment. In a 3D modeling software, it's more you have an object that is a mesh. It is a surface mesh. So your object, even if it's a solid object, you're just defining the surface of it.
You know,
so
everything you go ahead. Sorry.
So you're essentially in the 3D modeling software, you are defining an object by putting points in space. So you're putting basically it's a surface created of hundreds to thousands of points that have a 3D coordinate that is defined. So it's like if you make a cube, instead of it being a square that was... So in CAD, a cube would be a 2D square that is drawn onto a two-dimensional plane and then extruded in a third dimension a certain distance, making it a cube. And it would be defined by its like geometric properties of, okay, it's a square, meaning it's going to have 4 straight perpendicular sides, and then you know, they're a certain length, and they're on this plane. And then but in 3D modeling software, if you have a cube, it's going to be how many faces are in a cube? 6. It's 6 faces that are made up of a certain number of points that are interconnected together, creating a solid surface. Typically, the most common interconnection shape for connecting the individual points together is a triangle. I don't, off the top of my head, know the specific reason why that is, but
that's called a poly, right?
What?
Is that called a poly? P-O-L-Y?
What do you... I'm not sure.
I'm not either. That's why I was... Okay, if you don't, then we'll figure it out.
I'm not sure exactly what you're referring to by that, to be honest.
Like, so the triangles that you're talking about,
yes,
that in 3D modeling that hold together the shape. I
yes,
thought that was... They use 3 points because I'm assuming right now, I'm really just kind of reaching, that the 3 points help provide triangulation for the building of a shape, and it helps round things off. And I thought that was called a poly mesh. And that is, and that's why, like, sometimes you can go to like printables and you'll find like low poly 3D print. Check out the skull that doesn't have a lot of...
So
I was gonna go into this. I found, like, you know how much I love analogies. A lot of what you just said, the way that I'm picking it up is when I'm using CAD. For people, most people have probably used Photoshop. When I think of 3D modeling now, from what you said, I'm thinking of it like Photoshop, where Illustrator and Photoshop both end up giving you a visual file, or in this case, for what we're doing, a 3D object in space, except those are 2D objects. And Illustrator is going to use formulas and algorithms, code, mathematical code, to make sure that things are constrained and proportioned and are locked in. And I can do much of what you just described to make things parametric in a file. That's usually what a logo is. And it's done as you build it. It's created in space. But when I'm doing something in Photoshop, those pixels, they can't do that same thing. So like if you're in Blender and you've made a detailed file that you think is detailed, when you go to zoom into it at some point, you're going to see the defects of your art style as you've sculpted that object, which is much like the resolution in Photoshop. But of course, if you scaled something in CAD and you've made it parametric, or you've locked in all these, I think you said tangential relations to the X, Y, and Z axis, those things scale correctly and maintain their properties. But in this case, not only just their representational properties, but their not just their visual properties, but also their representational properties, like well, the material that you're using to design it. So that's kind of how I'm seeing it right now. It's like Illustrator allows me to be very fine, very specific about the object that I am trying to create, and that's a lot like CAD. And Photoshop is more like a paintbrush, where I can push pixels around that are limited in their scope, but also in their capability if you don't do it right. but at the same time is free form and allows for more artistic, creative expression, much like how modeling programs. And I know we were talking about the modeling programs. We only said Blender, but people may find themselves seeing things like Autodesk has one called Maya. There's one called ZBrush, 3D Max, Cinema 4D, Houdini, and there's more. But Blender is probably the one we know the most commonly. I know Cinema 4D is also a pretty popular one.
Yeah, I have heard of Maya and also ZBrush. I think ZBrush is also pretty popular. I don't know anything about it really, other than I've just heard of it. But that is actually a very good analogy, comparing it to Illustrator and Photoshop, where you're working with like a vector image versus just a
pixel. Yeah,
rasterized image.
Okay.
So yeah, that's I think I said brief. I don't think that was super brief, but just a little bit of an overview of CAD, what CAD is, difference between CAD and 3D modeling. Both can be used and are useful for 3D printing and in relation to 3D printing. Technically speaking, you could accomplish, most likely you could accomplish whatever it is you're trying to accomplish using either avenue, either CAD or a 3D modeling software. It's just that for certain things, one is going to either be easier to accomplish that task with, or it'll be either be easier, quicker, more efficient. So like if you want to create let's say you want to take a picture of Darth Vader and you want to create a 3D model from scratch yourself of a bust of his head. That's going to be significantly easier, more efficient to accomplish in a 3D modeling software. But let's say that you want to make some shelf brackets for your garage. That's going to be easier to accomplish in a CAD software.
Yep. Okay. Then that makes perfect sense to me.
So, yeah, that is introduction to CAD, 3D modeling. So I guess, what does this have to do with 3D printing? And this is just going to be for, let's say those who are just totally unaware. So for 3D printing, for a 3D printer, like a usual at-home 3D printer, you're going to take a digital file and the machine is going to turn it into a physical part. So like, your most common at-home 3D printers do this by using plastic filament, heats up the filament, extrudes it, and builds up a physical part layer by layer, one layer at a time. But in order to make that physical part, you have to start with a digital part, a digital file, and that digital file has to come from somewhere. And a lot of people who aren't engineers or super nerds, who don't just know how to do 3D modeling or CAD or anything, you're going to go to a file sharing website such as Thingiverse or Printables or MakerWorld now, to find your digital files, your files for printing those digital parts. But if you want to create your own parts, your own original parts, that's where CAD or 3D modeling comes into play. That's where you're creating your digital file for the physical part that you want to create.
Where I come in is I know nothing and would like to be doing this because there's times where, and I think this might be where it's going to where what we're doing now with this series is going to be for someone who goes into printables or things or Maker World, anything like that, and is looking in a repository for files to try to solve a problem that they have. Maybe their significant others asked, said, put that thing to use because you spend so much money on it. Why can't you? And you go to find that part that is to solve that case. I don't know any a hinge to a cabinet that broke, and it turns out you've typed it in vaguely and specifically, and it's not showing up on any of those. So you're feeling at a loss. This is going to be the way to solve that. Well, to get that. Maybe even to put it out into the cloud and help other people. But I know that's where I want to be by the end of this. And Taylor is going to help me do that painstakingly, step by step, in the most annoying way through lots of coffee.
So, I worked for just under 5 years in a rapid prototyping shop. We were prototyping, design, rapid prototyping, print farm, rapid prototyping shop. Anyway, the primary requests that we got from people for having stuff 3D printed were like parts for appliances that have broken, specifically knobs. So like let's say you break the knob on your washing machine and you can't find a replacement part for it from the manufacturer because you either just can't find it, they don't make it anymore, etc. So we got parts to replace broken parts on appliances, like just your typical home appliances like washing machines, refrigerators, that kind of thing. And then I think the main one the thing we got the most was parts for vintage or older cars that don't get made anymore, that aren't in production anymore. So we had a lot of people bring in parts from either just an older car they had that the part broke, or it was somebody who was restoring an old car, a classic car, a vintage car, and that the part they need isn't made anymore. So we would take their part or their broken part and replicate it. And I don't know if that's it's always, even now years later, it's kind of surprising to me that was the thing we got the most was parts for cars that don't get made anymore.
I got a pretty unique example, and I should preface it just to say that I did this myself. I did this dish with the previous guidance of you. But right now, I don't have enough knowledge and experience in any of this to be able to just do it again easily. I can't remember. Here's the example. As a graphic designer, I've worked in a large scale format printing, and I've worked with very large printers. And a company I was working for, there's a component that's reusable. These were ABS injection mold pinch rollers that held the material on these printers, a small part that I think it used about 16 of them at a time. And it turned out, for my example, that you couldn't buy those pinch rollers just by themselves. The best case scenario is it would come from like $150 package, and they would give you they'd give you like 12 of them in the package, not even enough to really solve the problem. And the company I was working for was like, God, if we could, because they get worn down. It's, they're using ABS inside of a metal flange, and as it rotates with the material moving, they wear down to the little pegs on them break. So they're considered a consumable, and the powers that be didn't make it easy to get more of them. I actually modeled out, and I did it in Fusion. I still have the file, the way Fusion works. I modeled this basically as much like a dowel rod roller. I can't think of the correct term, but with multi-layer texture on it that matched the original file, and I saved the company a lot of money that we could continuously print these things. And I believe they took my file and they are now using it at a print farm and getting it solved much easier there, because it was Hewlett Packard. Well, I probably shouldn't say that. Maybe it doesn't matter. Yeah, it was HP that was not giving it in to us so easily. They just didn't. I guess they didn't see that as a necessity, but turns out it was, because at the rate we were using them, we were just breaking at least 3 of them a week and constantly needed more. So definitely a good way to solve a problem that comes up.
Yeah, I mean, that's a really good example. I modeled a part for a guy a few weeks ago, I think it was last month, who had basically the same problem. Their company had a industrial plasma cutter that the cutter head had an ABS plastic guard around the cutter head nozzle, and apparently I don't know if this part was user error or machine error, but apparently the cutter head kept slamming into things and breaking the plastic guard off, and the company that makes it doesn't just sell just that part, they sell an entire new cutter head assembly, so it was costing them $2,000 a pop to get it replaced. And so the guy found me online and had me model him a new one, and now they're getting them for $40 just for the plastic part, instead of spending $2,000. So
yeah, big saver.
Yep. Any hoot. So yeah, introduction to CAD, a little bit about CAD 3D modeling, how it relates to 3D printing, and I guess we'll get into some I was gonna say 3D modeling, but some CAD modeling now.
All right. Please take the helm and ask me to do only the basic of things so that I can work my way back up. I hate to say it, man, but if someone asked me right now on the spot, and I know you can, I can't, to solve the problems like that I've just addressed that I did before. It was painstaking. It took me like 2 weeks to make those stupid pinch rollers, and it took me like 3 hours to just make this dish, and most of it, if you're watching this, please bear with me. The hardest part is, like, I can navigate Photoshop so quickly, but I don't understand the interface, which means I don't understand the base fundamental logic that goes behind the jargon and the layout of CAD with all the tools. I think that's probably going to be one of the things that really turns people off from this. Is it almost feels intuitive if you don't know the language, if you haven't been around people who have put it. It's like learning a different language, really. It really is, so that you understand the meaning and the when, the why, and the how for the options that you have in the software. And I've got to get that clarity. I think anyone else, that's what this is going to be for, is anyone else who also doesn't have that clarity and wants to build on it to where the subject just starts to make sense, and you can move inside these programs fluently and without the headache of not even know where to start.
Yeah, so what's really interesting is, on that note, so my first exposure to CAD was in middle school. I was in the 7th grade. And I was fortunate enough to go to a school system where we had an engineering academy that started in middle school and then went all the way up into high school. So I was first exposed to Autodesk Inventor in the 7th grade in my pre-engineering 1 class. I think that's what it was called. And it was like, I mean, the bare basics. It's like, here is CAD, here's what it is, and we were making like cubes and pyramids and cylinders, like basic shapes, just to learn the the very basics. And then also like we were quizzed and taught like the vocabulary terms and the layout. Like we were quizzed on the layout, like we had to know the names of all the stuff, like the toolbar, the menu bar, the yada yada. I don't remember. But so
No,
I guess I'm gonna brag a little bit here for a second. I was really, really good at it from like literally the moment I laid my digital fingers on the software. It actually kind of sucked a little bit because I was so much better at it than everyone else in my class that like we were like, okay, we're gonna make a cube. And it's like I was done making the cube before the teacher had even finished explaining how to make the cube, and I was sitting there bored out of my mind.
Good. Good.
So where I'm going with all this is what was really interesting to me is when I went to college to study mechanical engineering, I had already been using CAD for at least 6 years at that point. And so I go to college to do mechanical engineering, and I don't think it's until either the second freshman semester or maybe the first sophomore semester at the school I went to that they did the first CAD class. And it's required if you're going to do any engineering. It was required to take the CAD class. So I go into the CAD class. We're learning Solid Edge. I'd never used Solid Edge before. Me and all my homies, we hate Solid Edge. Solid Edge is the worst CAD software. Anyway, and most of the people, I would say 90% of the people in my class, it was about a 60-person class, had never used CAD before because, like I said in the beginning, I was fortunate to go to a school that had an engineering academy. Like most places didn't have that. So, I went to a pretty big college, and most of these people had never used CAD before. And it was so interesting after being exposed to it for so long that it had become just a normal part of my day-to-day life, like riding a bicycle or brushing my teeth. It was I had been used to doing it for so long that it was as natural as brushing my teeth or like taking a shower, that to be have my eyes reopened to seeing people who didn't know how to use it was really just crazy.
We have the same experience, yours being in CAD and mine being in graphic design, except my school didn't offer it. I know exactly what you're talking about. And
I don't remember where I was going with that story. I don't remember why I told that story, but that's my story.
No, it's your fluency. It's going to be that all of this is second nature to you, and it's not to me. And I feel that if you're able, because I'm hoping that I know already that that's going to translate into the fact that you're already ready to be a teacher. That's what it means. So so here I am, one of those people that you were around who have never really used it. I've used it successfully, but I am not fluent. And you have that second nature fluency where the tools at hand, the options available, and the strange layout that is kind of foreign to me, which I mean, it's not in the sense that I can translate and decode everything and that's available to me in, say, Illustrator, which probably looks slightly foreign to you.
Yes.
Then it's just that. It's a translation issue. Fundamentally, it makes sense.
Every time I look over your shoulder at you using Photoshop or Illustrator and I see all of the little pop-up floating windows you have open all over the place, I'm just like, it's just an overwhelming number of just little pop-up windows floating all over the screen. I'm like, how can you even see what you're doing?
But I have the meaning behind all of it already strung out in my head, and I know, and you do too in here.
Yeah. So, Yeah, I mean, I guess we've been rambling for an hour. We should probably get to the point.
Ooh. I am nervous. Because I'm going to stumble in this. It's going to look like I don't even know how to use a computer.
All right. We're going to start with Fusion 360. So I've got Fusion 360 open here up on the screen. And I'm going to try to I've already gone over this with Will one time. But I'm going to try to go over just the very basics. So I mentioned in middle school how one of the first things they taught us was the vocabulary and the layout. And at that time we were using Autodesk Inventor, and every CAD software, they all look fairly similar, relatively similar. It's like going from Google Docs to Microsoft Word. Like the skeleton is the same. It's the same with CAD, with Fusion, Solid Edge, SolidWorks. Those are the big three. But basically, you have your and each software uses different terms to define the layout components. So I mean, at this point, like, it's not super critical, or I mean, it's not really important at all that you know the specific or exact terms. And I've used so many different CAD softwares that, like, I don't remember which software calls, like, some of them call this is the toolbar, or this is the tool ribbon, or this is the menu bar. It's not super important that you get the exact name correct, but so many different.
My apologies. I just got asked for the potential for someone to see our live stream, so I am sending the link to them right now.
Nice. So basically, all your CAD softwares are going to have the same basic components. You're going to have your workspace, which is just the big space right in the screen. This is where your part's going to be. Some softwares are going to have a view cube or some other view reference. Autodesk uses Autodesk Inventor and Fusion use the view cube, which is basically just a little cube up in one of the corners that's going to tell you what it is you are looking at, like which plane you are looking at. So it's just a helpful little reference tool to, if you get lost in your little three-dimensional environment, to reorient which way's up, which way's down, etc. And then at the top you're gonna have your menu bar or your toolbar. This is where all of your like tool options are going to be. Like, this is where the button for creating a new sketch or creating features in Fusion specifically is. Like, this is where all your tools are. And then on your left is your goodness, what is your left is your are
you talking about like the build tree?
No, that's so in SolidWorks, and I think also in Solid Edge, your revision history is on the left here. It's stacked vertically on the left. In both Autodesk Inventor and Autodesk Fusion 360, your revision history is on a little toolbar here at the bottom of the screen, and it's laid out horizontally. So in Fusion here, so I haven't made a part yet, so there's nothing here. So the revision history down here at the bottom is empty. But this here at the bottom is your revision history. In SolidWorks and Solid Edge, I believe also in Solid Edge, it's on the left here, stacked vertically. But in Fusion and Inventor, this little tree here on your left is your like part tree or your body tree. I don't know the exact term Autodesk calls it. I'm honestly struggling to explain what it is. This is what I'm talking about, one of those instances where it's like it's so second nature to me that I haven't thought about it in a way that I would have to explain it, so it's difficult for me to explain it. It's like if you try to think about how you put on a t-shirt and you realize I don't actually know how to put on a t-shirt, or I don't actually know how I put on a t-shirt. I just know that my muscle memory knows how to do it. But anyway, so in Fusion, this is where your different like view settings are. So if I just real quick, I'm gonna make a cube. So we have a 20 millimeter cube, and you'll notice two things popped up here: sketches and bodies. So this is where I can toggle my view settings for your origin features. So every time you start a new part, you're gonna have origin features. So you have your three origin planes that it didn't. There we go. This is your origin, and then you have your bodies. So you can toggle the visibility of them over here, and then you have your sketches. So there's the two-dimensional sketch that the three-dimensional cube started with. And in Fusion and Inventor, when you take a sketch and you make it three-dimensional, it auto hides the sketch. But I guess the simple way of explaining would just be saying that this is your view settings over here on the left in this tree for viewing the different elements of your design or your part. So yeah, just again, super brief, your toolbar up at the top, that's where all your tools are, your view settings over here on the left, your revision history at the bottom, and then you got your little navigation view cube over here on the top right corner, just to help you make sure you stay oriented in the three-dimensional space so you don't get confused about which way's up or down or that kind of thing. And then you'll also notice now that I made the cube, two little elements popped up down here in the revision history. You have, and they are in order, so like they are in a chronological order. So the first thing here is the first thing you did. So we have the sketch where I drew the square, and then we have the feature, the extrude feature, where I extruded the 2D square into a third dimension, making it a three-dimensional cube. So that is like just super basic, the layout of Fusion 360. And then I'm gonna go over to Will's screen so we can look at how that compares to Ondsel. All right, Will, you ready?
Yeah.
Right.
You will see where I got hung up. I was trying to follow you, and I got about as far as.
All right. So currently, we're using Discord to share our screens with each other. Maybe we should switch to Zoom or something, or maybe Teams would even be better. I don't know. But for now, we're going to work with what we got. So currently we're using Discord to share our screens with each other, and since we aren't paying for Discord Nitro, we're limited to 720p. So unfortunately, looking at Ondsel on Will's screen here, it's going to be in 720p. But if you look, and every time I move my mouse, it's going to bring up the Discord window, which is annoying. But if you look, you'll see it's got the same workspace right here in the middle. You got your toolbar up here at the top. It's the same, you know, this is where your primary tools and stuff are. And then you've still got a view cube, which is your view reference, your navigation reference, but it's down in the bottom left down here. So that's, again, just to make sure you don't get disoriented. And then I'm gonna go back to Fusion real quick. You'll notice that when I have a tool active, so like let's say I hit extrude, I'm now like working on creating in Fusion, they're called features. So I'm working on creating a feature, this is an extrude feature, or this one would be a revolve feature. So when I click on the tool to start making that feature, a pop-up pops up on the right-hand side of the screen. This is where I set all my settings, and I define all my variables for that feature is in a little pop-up on the right. And in both Fusion, so in both Fusion and Inventor, they pop up as a little pop-up, so you can actually move where that pop-up is. I, in all my years, have always just kept it on the right, because, I mean, I've never really had a reason to move it anywhere else. But I think in SolidWorks, it's not a free-floating pop-up that comes up. I think it's actually a little panel that pops up from the right, and it's like locked to the right side of the screen. And then in Solid Edge, I don't remember exactly, but I think it's similar to SolidWorks, where it's like a little panel that pops up from the right hand. So when you go to create a feature, your settings for that are going to pop up on the right side of your screen. And then going back to Ondsel, you can see Will's got it in the sketch environment right now, so he's working on creating a sketch, but you've got your sketch tools over here on the right in a little panel that popped out.
Hey Taylor, I'm watching the stream right now
Yes.
on my phone, and you I'm trying to make sure. Okay, so I believe you are in. Okay, that's the confusing part.
So
You're streaming from. Okay, that's what's confusing. Now I feel like we're in Ondsel, and you're seeing my screen, right?
So yes, so the stream on YouTube is going to be behind True Live by a few seconds. So if you're watching it on the phone and you're listening to what I'm saying, like live through Discord, there's going to be a delay because the stream has a little bit of a delay.
And that's my screen we're looking at right now, and it's very strange that I'm not seeing everything that's on my screen actually, which is
yeah, I think that might be because of how you have your Discord screen sharing set up. It's just sharing your Ondsel window, so it's not showing any pop-ups that are popping up. So if there are pop-ups opening, yeah, I don't think we can see those.
No, like well, I'm looking at the so right now I have that square
Yes.
anchored in the bottom left. Anchor is to the X and Y Z, so it's just right.
Yeah.
And you can't see, or can you? Tell me if you can see the vertical X-axis green line. That is also a part of, because I see only the Y-axis red line.
No, I don't see a.
The green line.
No, I don't.
That's interesting because it is there.
Really? Oh, that is interesting. Man, we're gonna have to switch to a different. We might have to look at Teams next time. I don't think Discord is going to be the play. But anyway, so that's the basics for the layout. You know, most CAD softwares, they're going to be laid out pretty much the same. You know, toolbar at the top. It looks like in Ondsel here, you have your little view tree on the left here as well. So what do you think, Will? Did I miss anything?
Nope. It's just gonna following through as you do things. It's just gonna be like a build of one object at a time. Like I understand nothing about like it. Just despite what had the clarity of what you just gave me, the icons don't have proper definitions mapped to them for me yet. So I have no idea what I am getting into. Like I obviously I made the sketch and I knew to come here and use the create rectangle to do that, but you went from sketch to a 3D model that extruded itself into a cube so quickly that I was unable to quickly guess where that option is for me and get to it.
Yeah. So unfortunately, since we're limited to 720p, I cannot read any of the text on your screen, so I can't tell what I'm looking at.
So I'm going to be guessing a little bit here, but I've got an option that says leave sketch, view sketch.
So you're probably going to want to leave sketch.
Okay, now I have a 2D plane.
Yes. So what is... looking at the tool options you have at the top on your toolbar, what are we working with? What do you got?
From create a body, create a sketch, edit sketch, attach a sketch, validate, create a datum point, create a datum line, create a datum plane, create a local coordinate system, create a shape binder, create a sub-objects shape binder, this cool little icon of a sheep that tells me I can create a clone. I can pad. Now I think we're getting into extrusion options because it kind of defines it by sections on the same bar. I can pad. I can revolve or create a revolution. I can create an additive loft. And these days, like, I don't know what a loft is, so I don't know what an additive one is. I can create an additive pipe. I can create an additive helix, an additive primitive. Definitely don't know what a primitive is for that, but in here where things are already extruded, I suppose this says I can create a pocket, which looks like a bored out hole in a shape.
Okay, go back to the pad tool.
Pad. Here, yes.
Yep, just click it.
That's my secret. See, I would have not.
That is that's your extrude. That's your extrude tool. They call it pad. That's such a weird thing to call it.
Thank you. Okay.
Pad.
Yes, I'd like to be able to edit the software and change it to extrude, so it makes sense to me. But you can see how now I have it obviously anchored in that corner to the Z of the XY axis. I mean the 0, and no, that's why I can move it the way I'm moving it, because it's locked in there, I suppose.
Okay,
well,
so
really it's because I'm moving the plane.
I guess that's a good point. I'm gonna go back over to Fusion, and I'll just go over the super basic tools and what they do. So I'm gonna go back over to Fusion. So like I said earlier, in a CAD software, you're always going to be starting with there's a little asterisk with some fine print on this statement, but you're always going to be starting with a 2D sketch, moving it into and then turning it into a 3-dimensional object. So in Fusion, and in most CAD softwares, the very first button you're going to have on your toolbar, and it's typically going to be in the top left, is going to be new sketch, create sketch, something to that effect. Fusion calls it create sketch. So you click that, and then it's going to ask you to define the plane you want your sketch to be on. So since I'm starting from scratch with nothing here, the only planes I have are the 3 Cartesian planes. What are they? It would be XY, XZ, and YZ. So I'm just gonna do XY. So I'm now in the sketch environment for creating the 2-dimensional sketch. And in Fusion, you have your Fusion groups their tools by what they call the create tools and the modify tools. I'm gonna go back out of the sketch environment here real quick. So we're now back in the 3D environment, and you'll see we have again the create tools and then the modify tools. And it's basically going back into the sketch environment. It's basically the create tools are like you are making something from scratch. So like we have line, rectangle, circle, under create. So like I want to choose rectangle, and now I've created my rectangle. And then you have your modify tools. I'm gonna do offset, for example. Well, offset's not a great example. I'm gonna do fillet, for example. And basically the fillet, I'm not creating something new, I'm modifying something that already exists. And this is specific to Fusion and how they split it up. So I choose fillet, and now I can fillet or round over the corners of the rectangle I've already created. So, I mean, I think it's a pretty intuitive way of separating them. But, so yeah, you start with a 2D sketch, and then when you're in the sketch environment, you have your create tools, and that's where you create your basic shapes or sketch geometry. So let's recreate Will's dish. There's a few different ways we can go about that. I'm actually gonna start by doing a revolve. So we want to make a cylindrical dish with a revolve. I'm going to start with, if it were me, I would just draw this with lines. So the way I like to start when I very first start modeling something is I will throw down just the basic shape of the sketch first, and then I will come back and dimension it later, just because that's kind of the workflow that I like to do. So I'm using the line tool, and I'm actually gonna exit out of that. Oh, my software just lagged there for a second. So I've got the line tool selected, and then I've got this origin point right here. You always want to constrain your parts to the origin point. You always want to have it locked to the origin point so that you don't have your part just randomly floating somewhere off in space. You want it to be at 0, 0, 0, or relative to 0, 0, 0. It's good practice, so that I'm trying to think. The reasoning why gets a little bit more advanced, but it's just good practice to always have it locked to the origin. It goes into part assemblies, and when you're working with multiple parts in an environment, it's just how it makes it easier and better for defining them relative to one another. So I start my first point of my line at the origin, and then I'm just going to draw it. I'm going to keep drawing the shape that I want. So now I've got this little L shape here that I've drawn, and so I'm going to be revolving this using the revolve tool to turn this little L shape into a 3-dimensional dish. So I'm going to take this profile, this enclosed space here in Fusion, it's referred to as a profile. You can see when I hover over it, it highlights it. And I'm going to be rotating that. The revolve tool rotates that around an axis. And so for this specifically, it's going to be the y-axis here. So I drew it. Now I'm going to dimension it. And so the dimension tool is up here, or in Fusion, you can hit D on the keyboard, D for dimension. And I want the bottom to be 5 millimeters thick, and it automatically scaled the entire sketch relative to itself down to that size. So I want the bottom to be 5 millimeters thick, and then I want the wall over here to be 5 millimeters thick. And for this dish specifically, I always want the wall thickness to be the same as the bottom thickness. I just want the whole thing to be the same thickness. So instead of telling it I want both to be 5 millimeters, I'm actually going to delete that. And I'm going to use one of the constraint tools up here. And in Fusion, it's called equal. And basically, I click on the constraint tool equal, and I go to my first, let's see, what do I want to, objects, it calls it objects. So I go to my first object, which is going to be this line that I have defined and constrained to be 5 millimeters. So I click on that, and then I want this line over here to always be the same as this one. So now they will always be equal. So if I dimension this now, it tells me that it's over constrained, meaning it's already fully constrained and that it cannot be further constrained. So I create what's called a driven dimension, and that just means that that dimension isn't defining or constraining the object it's associated with. It is being driven by another constraint, and in this instance that being the equal constraint. So you can see that they're both 5 millimeters. So if I change the first one to 6, Now this one is 6. So that way, if I want to change the bottom thickness or the wall thickness, I only have to change 1 dimension instead of 2. So I'm going to change it back to 5. And then the length of this line right here is going to be my inner radius of the dish, because this is going to make up half of it when we revolve it around this vertical line here. So what was it, Will? 100 millimeters in diameter? I think it was 100 millimeters in diameter. So
you go 50 in the radius, right?
yes. So the inner diameter. So if we want the inner diameter to be 100 millimeters, so for this, we're going to make this 50 millimeters, half of it, because it's a radius. And then you'll notice, I'm going to undo that. Actually, I'm going to delete that, undo that. So one thing I glossed over, in Fusion, when you draw a sketch, I'm going to draw a rectangle here real quick. So I have this rectangle floating here. All of its lines are blue, and that means that they are not constrained, meaning like if I click on the corner and drag it around, it'll move, or if I click on and select the whole thing, I can just move the whole thing. It's not constrained in any way. It's just completely free floating. I'm going to delete that. You'll notice these 3 lines down here on this L bracket, this L shape we made, are white. That means they are fully constrained. They are locked in. They're mathematically defined. And so if I click on this point and try to move it, I can't. If I click on this line, I can't move it. It can't go anywhere. I can move this point. You'll see these 3 lines are still blue because we haven't defined or constrained that yet. So I can move this, but I can't move this because it's constrained. So anyway, back to, so you'll notice when I click this and dimension it, now these 2 lines turned white because they are constrained. They can't move now. So all that's left is this line is blue. So we have to define how tall we want our dish to be. So we want the inner wall height to be 20 millimeters, let's say. So dimension tool, I want this from here, this point to this point. This is going to be the inside height of our dish. So I'm going to tell it I want it to be 20 millimeters. And now everything in this sketch, it's all white. It's fully constrained. You always, in CAD, you always want to fully constrain your sketches so that, like I said earlier, CAD is parametric. So when you go back to an earlier sketch or an earlier feature and you change something, that's going to update everything that comes after it. So you always want everything to be fully constrained so that you can go back and edit it and it not mess up features later on down in the revision history. So my sketch is fully constrained. I can now hit finish sketch, and my software is going to lag for some reason, probably because I'm recording and live streaming and got Discord streaming a screen open. Anyway, so we're now back in the 3D environment, the 3D workspace. So I can now, so I got this 2-dimensional L shape. It's a 2-dimensional profile, and I can look at it in 3 dimensions. You know, you can see right here, it's 2-dimensional, it's flat. Looking all around at it. So I now want to revolve it into a dish. So I go up here to the revolve tool, and the revolve tool takes a profile and rotates it or revolves it around an axis. So I click the revolve tool, and in Fusion, so I need to define a profile and an axis. So the profile I want to revolve and the axis I want to revolve around. In Fusion, if you only, when you first start a part, if you only have one profile, like we only have one profile here, whenever you select a tool up here, it automatically selects that profile. It's just a quality of life feature, so I'm going to deselect it. So I got to select the profile, and then I go, and now I need to select the axis. So we're going to be revolving it around the axis right here. And then this is showing me a preview of what it's going to look like. So this is a full... I can define the extent of the revolve. Right now it's defined as a partial, but it's set to 360 degrees, so effectively it's a full. But if I set this to 180, I just get half of a dish, a half circle, half dish. Or I can do 270, and I will get 3/4 of a pizza.
Oh.
Anyway, so I'm going to change the extent to full so that it will fully revolve it, a full 360 degrees. So we have a full dish here. And then you can tell it what operation. Right now, the only operation we can do is new body. And then I just hit OK. And now we have a dish. In one sketch and one feature, one revolve, we have a 3-dimensional dish. And then let's say we want to make can I turn that drop shadow off? Actually, visual style, sorry.
I was wondering what that plate in the background
Ground
was.
shadow, turn that off. So
Okay,
that
cool.
is so right now, because the plane I picked to do the revolve on, you know, looking at the view cube here, I have the dish built on the XZ plane, so it'd be like if it was standing up on its side, and it's got this shadow here just so I can see that, like, oh, the shadow is like the plane where, like, the quote-unquote ground is.
Mm-hmm.
But I don't want that. We don't need that. So I'm going to turn that off, because that's not important for this. Ground plane? Whatever. Anyway, so now we have this dish. So let's say we want to make it a little prettier. You know, we don't want our little bunny rabbit to cut himself on these sharp corners here. So we want to round over these corners, these edges here, make them a little softer, a little nicer to look at. So then we're going to go to one of the modify tools, because we're not creating something new, we're modifying something that we've already made. So we go to the modify tools, and it's fillet. And I'm going to select both of these top edges here. So now I'm going to be filleting or rounding over both of these top edges. And so I made the wall thickness 5 millimeters. So if I round over both of them, and I do a 2.5 millimeter radius for both of them, I'm going to get a full round over on that top edge. Like, it's a full circular round over. So if I just do 2 millimeters, you'll see it's rounded over here, and then there's flat space in between them. So I'm going to do 2.5 to get the full 5 millimeters of the wall thickness to get that full round over. So now it's a full rounded over edge. I'm going to hit OK. So now that's the edge. So now I want to round over. Okay, this is going to be a little bit more advanced, but why would you, aside from aesthetics, why would you want to round over your edges? In part design, model design, part creation, the engineering behind why a part is designed a certain way, sharp corners create stress concentration zones. So when you have a part, and this is any part, any object, when you have an object and you have a sharp 90-degree corner, that corner is going to be a concentrated point for stress to accumulate or build up on that part. Basically meaning that when force is applied to that object or that part, that's where it is most likely going to break the part is at that stress concentration point.
Oh, I got a question.
Yeah.
Are you saying that with the corners, and we've filleted, we've rounded these edges, this reduces the finite point, which is at the edge of a corner, it gets ultimately, I'm assuming, as an analogy, it gets to the 0 point as thin as paper in theory, and that is the initial point for which a stress crack could then generate and fissure across the object.
Yes, basically. So by rounding over the edges, you are eliminating a singular point for stresses to accumulate or build up on the part. And it's basically like taking a point load and spreading it out into, instead of being a point load, being a spread out load. You're spreading out the surface area that load is being applied on. So you're increasing the strength of your part. So with that in mind, so that's why for something like this, I know it's just a little dish and it's not going to be like super important that it's super strong, but just like as a best practice general rule of thumb, that's why you would want to round over your edges. Then also in 3D printing specifically, and in designing for 3D printing, because of how 3D printers work, it is also best to always round over your edges, because in a 3D printer, an FDM plastic extrusion 3D printer, when the print head is moving around, let's say you make a square, when it goes to print one wall, it's moving in a straight line one way, and then it has to come to the corner, so it's going to be moving in a straight line. It comes to the corner, stops, and then has to change direction to go the other way for the other wall. And at that hard 90-degree corner, it is going to have to come to and this happens really quickly, so you usually can't see it visually, but it has to come to a full, complete stop moving, and then move in the other direction. Whereas if that 90-degree corner was rounded over with a fillet, and it had a radius to it, it would not have to fully stop moving. And that eliminates a lot of issues with 3D printing. That prevents you from having material buildup or blobs on your corners. That can increase your print time, your print speed, because your print head isn't having to come to a full stop and then reaccelerate back up to speed. And again, you're just going to get a stronger part because you're not going to have a concentration point for stresses.
For clarity, so what we're talking about is a fillet that has rounded the edge over, as you did in your initial sketch with the cube when you were first showing fillets. That happened on the X and Y axis, but it actually benefits the walls going up on a part that's being designed in the Z axis as it's being printed. So it allows those Z axis walls, that's how we've extruded it, to have the left turn isn't a hard left turn, it's rounded over, so the print head, the printer, the nozzle gets to continue to go. Is that what I'm getting?
Yeah, it's kind of like how it's like having a NASCAR race. You know how a NASCAR racetrack is like oval shaped, so they when they take their turns, like they have to slow down a little bit, but they're not coming to a full stop. But it's like, you know, you have your NASCAR racetrack turn versus your if you had just like they had to come to a T intersection where they had to come to a full stop and then turn. It's like that. But
yep.
Anyway, so now we're going to look at with all that in mind, now we're going to look at rounding over and filleting these last two edges. And this so these two edges are at the intersection between the bottom of the dish and the wall of the dish. So they're at like a corner. They're a corner at a corner. So this is a little bit of a slightly more advanced feature, but in Fusion, if you go to inspect, and you look at the inspect tools, you can do what's called a section analysis, and basically that lets you it does a planar cut to your object and lets you view the cross section, a specific cross section of your part. So it's easy if I just show you how it works. So I have the section analysis tool selected, and now it's asking me what plane I want to use to do my planar cut, and I'm just gonna pick this one. So now I can change some of the options, but this is what I want, so I'm just gonna hit OK. So now I'm looking at the center cross section right here of the dish. If I go over here to my view tree and I click the drop down on analysis and I turn the visibility of the section analysis off, my full part is still there. It's just when I have the section analysis turned on, it's hiding half of it so that I can look at its cross section. So that's going to come in handy here in a second. So looking at the cross section of this part, you'll see we have these hard 90-degree corners here, and in any part, a metal machined part, an injection molded part, a press formed part, a 3D printed part, this corner, this hard 90-degree corner right here, right in this space, is going to be a stress concentration point for stresses. And so we want to round over this interior corner and the exterior corner to prevent that. And it is best practice to have a constant wall thickness for your parts. For injection molding specifically, because of how injection molding works, you always want your walls to be the same thickness throughout, everywhere, as much as possible, to avoid warping or sinks or stress concentration areas. So, and in aesthetically, it also just looks better to have a constant wall thickness. So if I were to do a fillet on this inside corner and this outside corner, and I want it to be 3 millimeters, I'm just picking this arbitrarily. So they're both a 3 millimeter radius fillet, and I hit OK. If I look at this cross section here, this radius here is 3 millimeters, and then this radius here is 3 millimeters. And it might not be super easy to tell, but going from this wall up here that's 5 millimeters thick to the bottom down here that's 5 millimeters thick, this area in the corner right here, where it transitions from wall to bottom, is thicker from this point here to this point here. It is thicker than 5 millimeters. So that would be, you have an inconsistent part wall thickness right in this little zone where it's thicker than the 5 millimeters. So this area is gonna be a area where stresses will concentrate on the part. So to avoid that, I'm just gonna hit undo to undo those fillets. To avoid that, I'm gonna put a fillet on the inside corner. It's gonna be 2.5 millimeters, just so it matches the top up here. And then for this outside corner, I'm gonna do another fillet, and this is gonna be the inside fillet diameter or radius plus the wall thickness. So that's going to be 2.5 plus 5, so 7.5 millimeters. And now throughout this entire area, it's 5 millimeters thick. This wall throughout this whole curve is 5 millimeters thick. So now the wall thickness and the bottom thickness, the entire wall thickness of my part, is all the same. So there's not any singular point in here where stresses are going to accumulate. So this is like the optimal design in terms of like strength or load bearing for this part. And then I'm going to turn the section analysis off. It is also an aesthetically pleasing looking little dish.
Very nice. Okay, I like that. So that's an easy formula to remember. It's just the inside fillet plus the wall thickness.
Yep. And that's it. That's it. That's this dish. Done. We are able to make the basic shape of the dish with one sketch and one feature or revolve, and then we just had to do 3 little fillets to round over the edges, and now we have this little dish. It's ready to be 3D printed. I was gonna say injection molded, but this is actually not fully optimized for injection molding, so I'm not gonna get into that. That's way too advanced for the scope of this video. But anyway.
In FDM manufacturing, 3D printing, and in someone's home, that's good to go.
Yep. So
nice. Well, as you can see, I have. I don't know if you can see.
Yeah, I just switched over to Ondsel. I'm looking at Ondsel now.
I haven't made a dish, and I actually. So there's definitely going to be a slowdown for us in the translation from Fusion to Ondsel, where you are also going to have to learn Ondsel because I am going to have to learn Ondsel, and that's gonna slow us down in all of these a little bit in the translation. Some of the things I could not find while I wanted to make sure I was prioritizing watching you. I could not figure out how to get the cross section in here because I could not find the features. I think I should come over here in the top right and okay out of my chamfers now. I mean, not chamfers, my fillets. I'm done with that. So I have my part. I could not get the cross section. And also, I did learn this while we were going on. The viewers couldn't see this, I don't think, but I learned how to do my sketch. I did not do my sketch with the features that you described where this was locked in. I couldn't move that fast, but on the fly I figured out how to use what was I using? This one. I was using create a polyline, and I did my polyline, and I basically used my grid and kind of just got the shape. So this is that blend and transfer between using CAD and using 3D modeling, where I used CAD, but I used it as flippantly as I might use 3D modeling, where I just eyeballed it. And I got I basically just eyeballed this while you were talking about things because I wanted to make sure I was trying to follow you, and got a shape that I found to be aesthetically pleasing for balance and the final part that I thought was going to be once it revolved. And I came up here, and after I left the shape, so I leave the sketch, and I had that I did have that 2-dimensional plane here hollowed out, and then I just came up and I hit revolve or revolution, and it gave me that part. Then I basically just sectioned out these things. I don't have a good grasp. Let's go back to the sketch on what my dimensions are right now. I would think if I clicked on it, it would tell me. But it doesn't. It doesn't do anything until I drag, and I don't actually know what those mean. I guess one's letting me know that I'm dropping down 40 inches or 40 millimeters, going down to 30. Let's undo that. But I did find it cool that if I grabbed here, that's all it took right there, leave sketch, to completely change my shape on the fly super fast. That's, for me, that's nice. That I can easily do that. But I on this model have not properly cross-sectioned and made sure that I have a consistent wall thickness in this bottom fillet in relation to, not that I don't understand the formula you said, but because I don't know exactly how to properly do it in Ondsel. So that's gonna be a small headache. If you know where this cross section might be or where I should start looking, I will definitely.
I have absolutely no idea where that's gonna be in Ondsel.
Right. Okay, that's
No
fair. So
clue.
that, yeah. So maybe in the future videos, I'm just gonna have to use Fusion, because by using Fusion, I will be able to follow along quicker and at least begin to learn the jargon so that I can translate this into Ondsel. And really, it's just going to be a quick Google search for me, I believe, to find out where cross section cut in Ondsel is. No, it may not, because the reason I'm using Ondsel is there's a very limited amount of content online, YouTube at least, about Ondsel, to my knowledge, and I might be wrong about that, but I couldn't find the simple things I wanted to get me started. It seemed like everyone was already more fluent than me in the way they were doing it, and that could just be the case for why I couldn't find what I wanted. But I didn't know what I was looking for. But Fusion might be the way to go for me on the next lesson. This, however, I am not complaining, because I can do this more fluently than I did it the last time, and that is right what I was hoping for. So I'm not upset with the fact that this dish happened so much easier than the last dish. It's weird. It seems like people might even think I'm holding up the same file, but it's not. It's just now they go back, it's unnamed. That was just created on the file. I showed it. Yeah, because that was way easier. Just making the L shape and revolving it.
Yeah.
Instead of a circle and extruding upward, and then trying to put a wall thickness on it with 2 circles.
Yeah. So I'll show. I'm gonna go back to Fusion, and I will show one more thing, and then I think we're gonna wrap up the stream for today's. I think we're gonna wrap up today's. But what Will is referring to, I'm going to, in the same part that I just did, I'm going to hide the first dish. I'm gonna actually make a new component. Okay.
Are you about to show the multiple ways of skinning the cat kind of thing?
Yes, I am.
That's a good thing to show, because this was easier than what you're about to do.
Yeah. So, when I first explained to Will and showed him how to make this dish in Fusion, I did it differently. I did it how I would have modeled it. And basically, like he just said, there are multiple ways to skin a cat. There are multiple ways to model this in Fusion or in any CAD software. So I just showed. Let me go back to the parent component and turn the body back on. I just showed how to do it with a sketch and a revolve. I'm now going to show a different way of doing it using no revolves, just extrusions. So I'm going to go create a sketch. Use my view cube to reorient myself. I'm going to draw the sketch. And now I'm going to start with a circle. And I want a 110 millimeter circle. I'm gonna hit finish sketch. So this is gonna be my base, the base of my dish. And I'm gonna use the extrude tool. I'm gonna extrude it. I want the bottom to be 5 millimeters thick. I'm gonna extrude it 5 millimeters. So now this is the bottom of our dish. And then I'm gonna go create another sketch on the top surface of that. I'm gonna use the offset tool. And I'm gonna offset its outer diameter. I'm gonna do negative, so it goes in 5 millimeters. So now I hit finish, and then this profile right here is gonna be our wall that's 5 millimeters thick, and I'm gonna extrude it 20 millimeters up. And now I've got the same dish with the 100 millimeter inner diameter and the, come on, work with me here, 20 millimeter inner wall height, and the walls and the bottom are all 5 millimeters thick. But I did it using 2 sketches and 2 extrude features, so like double the amount of stuff going on. And technically speaking, this is less efficient for future proofing, because if I want to go and change some aspects of the wall thickness or the bottom thickness or the wall height or the diameter, I have to know what feature down here corresponds to which of those things I just described to be able to go find it and edit it. Whereas if I hide this component and go back to the parent component and look at the first body, with the revolve, if I want to change anything about it, anything about this dish, all I have to do is go back to the original sketch and change the dimensions of the original sketch. And I can change the wall thickness, the bottom thickness, the wall height, the diameter. Whereas with the doing it this way, it's either going to be in this sketch or one of these other features. So this is another way you can do it, but it is arguably this is the less efficient method of doing it. So,
which is a good idea to think about your part and what you're doing up front, because it could save you time.
Yes, that is something that takes practice, but future-proofing your part design from the very get-go is also another important skill in CAD, so that when you have a part, you don't have a arbitrarily bloated revision history that's confusing and difficult to navigate.
I can see how that does get complicated on some of the parts you've made.
Yeah. Well,
just to know when and what.
Yeah. Well, what do you think, Will?
I got that done much easier, and I know a lot of it had to do with the fact that you were right here and I was following along. But really, I'm doing it in a different software, so I'm becoming slightly more fluid in Ondsel. I feel that, and I'm gonna have to think about the next thing that I want designed. Oh, maybe the next one could be making three-dimensional, aesthetically pleasing, stylized numbers. So it'd be cool to learn how to take. So like in Photoshop, I can just type something up. Say I want a series of numbers that I'm going to provide to somebody as a sticker. But in this case, I want to make it for them so that it's a 3D model, and they can actually maybe put it on their vehicle and Bondo it in. I don't know. Maybe it's a decal that they want, an emblem that they want to like build into their vehicle or put on a wall. And I would like to be able to just type in a word and then 3D print it, and then be able to put those up on the wall. That'd be cool.
Yeah. Yeah. That's actually not too difficult, and but yeah, I think we'll save that for next time. So.
Okay. Sounds good to me.
All right. Well, I guess that's going to do it for today's stream. We went over some of the basics of CAD, what CAD is, the difference between CAD and 3D modeling, how that relates to 3D printing, and we talked about just the basics of Fusion 360, and a little bit about how to use it. And I guess next time we'll be looking at how to do text. How to do text, words, numbers, alphanumerical characters, that kind of thing, as well as delving into some of the other features, like probably we'll go into Loft, that kind of thing.
Okay.
So
that's another thing. Do we just as a maybe like at the end of the next video, will you be able to show me how to take, say I have this dish here. What if I wanted to put a pet's name on the outside and have it extruded and attached and going around the the rounded surface of the dish? Can that be done?
Yes, that would be a emboss, and yeah, that can tie into the text. Yeah,
Cool.
So
Cool. So we'll do we'll do a basic text just where we're actually able to 3D print characters individual. So when they're printed on the build plate, they come out individually, and you can move them around. You have them, and then one where I can attach it to an already existing model that I have.
Yep.
Okay.
All right. Well, thank you everybody for joining us, and we'll catch you next time.
All right. Take care.